Okay, now we're doing a more formal introduction and explanation of the binomial theorem that we did previously on one of our block days. So this is the strict definition of the choose function, or the n choose k, the combinations. So n choose k is read as n choose k. It's a combination, and if you have n elements that are indistinguishable and you choose k of them where the order doesn't matter, this is the number of ways that you can perform this in. Check another video if you'd like to see an explanation for where this formula comes from. But just to apply the formula, 7 choose 3 means that you have 7 items, you're choosing 3, so we're going to do 7 times 6 times 5 over 3 times 2 times 1. So you get to just take 7, choose 3. 3 times 2 is 6, those cancel. That's going to be a 35. 12 choose 0. 12 choose 0 means you have 12 items, you're going to take 0 of them. That, of course, if you're only going to take 0 items, that's just going to be 1, so I won't do too much more work on that. For the next two examples, 10 choose 8, you can either follow the formula, try to use the example I did up there, or let me show you where our calculator buttons are for these. The calculator buttons are math, probability, choose. And so you can see, well, that one actually already has options in there. Let me clear that all out. If I'm going to do this, I need to do 10 choose 8. So I can go 10, math, probability, choose 8. That's the notation in the calculator for 10 choose 8. 10 choose 8. When I do this in the calculator, I end up getting 45. And then over here, it's 10 choose 2. So I do 10 math, probability, choose 2. And that also gives me 45. And just to bring us full circle, since we're doing this more formally than we did last time, let me do this one in the same way as I did the problem up here. So I use the same technique. If I have 10 items and I'm choosing 2 of them, there's my choices for the first item, there's my choices for the second item. Divide by the number of rearrangement, and 2 divided by 10 is 5, 9 times 5 is 45. Okay, so that's how the binomial coefficients work. Okay, now Pascal's triangle allows us to be able to write all of these binomial coefficients. If you write these out and just calculate these, the top row is 1, this is 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. And this provides what's called the Pascal triangle. The Pascal triangle is the triangle of the binomial coefficients chosen by this choose operator. This choose operator. There's a lot of fancy patterns that happen in here, as we saw in class during our block day. But for our purposes, what's most useful is how it leads into the binomial theorem. And the binomial theorem says that x plus a to the power of n is equal to those binomial coefficients, those Pascal triangle coefficients, multiplied by the powers, where the powers sum up over the x's and the a's in increasing and decreasing order. So most importantly, how do we actually apply this to an actual problem? Right? So if we wanted to take x plus 2 and raise it to the 5th power, this would be x to the 5th, x to the 4th, x cubed, x squared, x, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the squared, and 2, and then the coefficients, 1, 5, 10, 10, 5, 1. So the final answer for this expansion would be 1x to the 5th plus, okay, x to the 4th, 5 times 2 is 10, so you end up getting 10x to the 4th. In this one, we have 2 squared is 4. 4 times 10 is 40, so we get a 40x cubed. 2 cubed is 8. 8 times 10 is 80, so that's an 80x squared. 16 times 5 is also 80, so that's an 80x. And then finally, 2 to the 5th is 32. So notice that this gives us a big advantage because instead of having to actually FOIL or distribute out x plus 2 to the fifth, we can do it much more efficiently by using the binomial theorem. Okay, let's do it in a more complicated example. The coefficients are a little bit more painful here. 2y to the fourth, 2y cubed, 2y squared, and 2y. And then we have a negative 3 to the fourth, negative 3 cubed, negative 3 squared, and a negative 3. All the while kept track of our binomial coefficients from the Pascal triangle, 1, 4, 6, 4, 1. So what would the final answer come out to be here? 2 to the fourth is 16, so this would be 16 y to the fourth. Then we have 2 cubed is 8. 8 times 4 is 32. 32 times 3 is 96. Minus 96 y cubed. Okay, 2 squared is 4. 4 times 9 is 36. Times 6 is 216. So we get a 216y squared. 3 cubed is 27. 27 times 2 is 54. 54 times 4, oh, that's also 216. That doesn't always happen. But then 3 to the fourth is positive 81. So there, again, very efficient way of figuring out what the quantity 2y minus 3 to the fourth is without having to do 2y minus 3 times 2y minus 3, then multiply that by 2y minus 3, and just hope that you get it right with all the arithmetic. Okay, our last page of examples here is to use this idea to find a particular coefficient or term in these examples. Okay, first one's asking for the coefficient of x cubed. So I definitely want the x to be raised to the third power. Since our overall is to the 10th power, that means I need the negative 3 to be raised to the 7th power, because our powers will always add up to 10. And that also means that out in front we're going to have 10 choose either 3 or 7. It ends up not mattering which one we choose, so I'll do 10 choose 3. So I need to figure out what 10 choose 3 is. That's 10, 9, 8 over 3, 2, 1, 3, 4. So that's 120 x cubed negative 3 to the 7th power. Negative 3 to the 7th power. I can't do that. That's not going to work. So negative 3 to the 7th power multiplied by 120. Looks like I'm going to get negative 262,440 x cubed. And the problem was only asking for the coefficient, so I'll just put a box around that and a smiley face. Okay, B is asking for the third term in this expansion. So we're going to take the 3x, and we're not going to raise it to the 8th or the 7th. We're going to take it to the 6th, which means the 2 would have to be raised to the 2th power, so we get 6 plus 2 is equal to 8. It also means we need a leading coefficient of 8 choose either 6 or 2, so I'll do 8 choose 2. 8 choose 2 is 8, 7 over 2, 1. That's a 28. 3 to the 6th, x to the 6th, and then a 2 squared, which is 4. So again, the numbers are getting big, so I'll just do this out. 28 times 3 to the 6th times the 4, 81648, and that's x to the 6th power. And that would be the third term. Okay, now getting a little bit more fancy. We want the x to the 6th, but I've given you difficult things to work with. So we have to somehow make this, the powers have to add up to 9, and I need to make sure that I get an x to the 6th. So let's just do a little bit of trial and error over here. If I do x to the squared and a 1 over x, technically a negative 1 over x, and I raise that to the 4 and the 5. That would be an 8 minus 5. That would be 3. That's not going to work, so I got to get more. So let me go 5 and 4. 10th, x to the 4th in the bottom. Yep, that's going to do it. That's going to do it for us. So we want 5 and 4. So that's what motivated me to get x squared to the 5th negative 1 over x to the 4th. Notice the 5 and the 4 add up to 9. And then out in front, we're going to have a 9 choose either 4 or 5. This time, this one's got a little bit too much number in it, so I'm just going to use the calculator. So math, 9 math choose 4, 126. This becomes x to the 10th, and this becomes 1 over x to the 4th. And do you see how the work I did at the beginning allowed me to figure out that x to the 10th over x to the 4th gives me the x to the 6th, and there's our 126. Question again was only asking for the coefficient, so that's 126. Okay, final problem. The coefficient of x squared. So similarly, we're not going to be able to just cancel these out nicely, so I'm going to have to just take a shot here. Our radical x, 3 over radical x. And let me guess. I'm not going to go 4 and 4. Let me go 6 and 2. Radical x to the 6th would be x cubed. Radical x to the square would be x to the 1st. And x cubed over x to the 1st is going to give me x squared. Nice, I hit it right off the bat right there. So, radical x to the 6th, 3 over radical x to the 2, 8 choose 2, 8 choose 2, 28. Radical x to the 6th is going to be x cubed. 3 squared is 9 over rad x squared is x. X cubed over x yields x squared, which is precisely what I wanted. That's what I was doing at the beginning. So I just need to know what 28 times 9 is. And that's 252. And so our coefficient there is 252.